Welcome to day 2 of simple harmonic motion. Yesterday we talked about springs, and so today we're going to talk about a pendulum. And we're going to watch the energy as it goes between kinetic and potential energy in the swing. So let's look at that first. If we look at this diagram, at point A, the pendulum is at its lowest point, so therefore it has the lowest potential energy. And because it is a system, that must mean that its kinetic energy is at its maximum, which would make its speed also at a maximum. If we look at points B and C, we know now that the potential energy is going to be at its highest because now it's at the highest point in its swing, which would therefore make the kinetic energy at its lowest point. And that would also mean that the velocity would also be at its lowest point, which if you've ever watched a swing or pendulum, it actually stops and turns around. And so that would make sense to us. Then at any other point, then we know those two values cannot be zero because it must be some balance between the potential and the kinetic. So it all kind of makes sense when you start diagramming it out. There are formulas that we will deal with. We're going to deal with the top formula for the pendulum for today's homework. And we know that T is going to be the period. We learned that yesterday when we started off with our notes. Is equal to 2 pi and then the square root of the length of the pendulum, the L, over the gravitational pull. So a pendulum, even though it had the same shape on different planets or different surfaces, it can vary depending on the gravitational pull. And so that's what we're going to deal with. So here are two problems that we're going to work on the podcast, and then we will also talk about these and do some more tomorrow in class. So the first thing we want to do is talk about what is the period on Earth of a pendulum with a length of 2.4 meters. So we're going to set up our formula. So T is equal to 2 pi, the square root of the length over gravity. So we're looking for T, so we're just going to plug in the numbers we know. 2 pi and the square root of the length, which is going to be 2.4 meters over our gravity, 9.81 meters per second squared. And if we plug that into our calculator, we should get an answer of 3.11 seconds. So try that and see if you agree with me. Okay, the next question is asking us to solve for a different variable, so it's a little bit more complicated, but not by much. So how long would a pendulum be in order to swing back and forth in 1.6? So that is our period. So we have the period is 1.6 seconds. I'm going to look for the length. That's the part I don't know, but of course I do know my gravity. So I'm going to go ahead and plug the information into the formula. It's right above, but I'll write it again just so there's no questions. So 1.6 seconds is equal to 2 pi, the square root of L, which I don't know. That's what I'm solving for, over G, which is my 9.81. In order to get rid of the square root, I'm going to square both sides. And that is going to give me 2 pi squared times L over 9.81. And if you solve for that, you will end up with 2.56 is equal to 2 pi squared L over 9.81. And then if I divide the or multiply both sides with a 9.81, I get 25.1136 is equal to 2 pi squared L. And if I divide both sides then by 2 pi squared, I'm going to find out that L is equal to 0.63 meters. So check your work, check my work, and we will start there tomorrow in class. Good luck.